before you find a common denominator. Here you go. 7. What can I factor x squared minus 36 into?
X plus 6, x minus 6.
And second fraction. How can I factor that one? Let's hear from 3. X squared plus 6x.
I'm sorry, I was.
X squared plus 6x. What can I factor that into?
You can do perfect square. Oh no, you can't. Sorry. Just x and then x plus 6.
Ready to find the common denominator now. Look at both denominators we just factored. What's in common? What do they have in common? A full term they have in common. 16?
X plus 6.
Yep. That's a full term they have in common. I don't think they have anything else left in common. Doesn't look like it. So now you got to tell me what's left over so I can put that in my common denominator. What's left over? It's 8. What's left over?
X and x minus 6.
Great job. Okay. Please look at the first denominator. What is it missing that the common one has? Because that's what I'm going to multiply by. Okay. Look at the first denominator and the common one. It's missing something, and I need it to multiply the top by it. What is it missing? 18. Tim, what's it? X. Thank you. So I'll multiply the 2 by x and get 2x on top. Here's where I'm going to get a lot of you, even the studs in here, I'm going to get on this next part. What's this missing? This is not the trick either. What's x plus 6 missing? 5. What's it missing? X minus 6. Yep. All right, and let's stop right there because this is where you might get trapped. What am I doing to these two fractions? Subtracting. So when I go and distribute right now, I am not going to distribute a 1. Why not? Because it's attached to what? Negative 1. So when we distribute, we're going to distribute a negative 1, not a positive 1. All right, so watch out for the subtraction. I kind of warned you yesterday, but now it's in full effect. You are not distributing a positive 1. They go together. They're attached. So I'm going to distribute a negative 1 and end up with what? Negative x plus 6. Yep. There you go. All right, what's left on top? 10. What's left on top?
3x plus 6.
3x?
Yeah.
2x minus x?
1x.
X plus 6. Yep, good. And I got my denominator. I'm still not going to box this in. Why not? It's not reduced. 7. Why isn't this reduced?
You can get rid of the x plus 6 on the top and the bottom.
Correct. Got it. Good. All right. How far have we come? What's left over now? What should I be writing here? 3. Take over here. What's left on top?
1.
Yes. Thank you. Thank you. A 1 when everything's crossed out on top. And there it is. Anything? You got number 3 on your own. Go. I think it's time you do one on your own, and then we'll do 4 as a group. Not common denominators, so but you notice you can factor them, so try to factor them. figure out what you're gonna multiply the 6 by, right?
X plus 4.
Multiply the 3 by and do it, okay? Okay, let me start going over this. You should factor both of them. Your common denominator, x plus 3, x plus 1, x plus 4 in any order. All right, so all three of those. You should have multiplied the 6 by x plus 4, multiplied the 3 by x plus 1, because that's what was missing from each. After I distributed combined like terms, I'm down here now, 9x plus 27. That's what I end up in the numerator with, 9x plus 27. But I didn't box it in because I'm not done, because 9x plus 27 can go further. 14, how?
You could take 9 out of it, so it'd be 9 times x plus 3.
Got it. And we could keep growing further. How? 8.
The x plus 3 counts.
Good job. So here's my final. 9 over x plus 1 times x plus 4. That's what I'm working with now. Any? Yeah, sure. Anything we got going on here you want to talk about? All right, let's do 4 together. There's no, I think you could do it on your own. There's not really any surprises here, but maybe one little surprise, but we'll see. All right, I look at the denominators. They're not the same. I can factor 1 out of the 3, right? X squared plus 7x plus 10. What do you got? 17. How do I factor that?
I got x plus 5
Yep.
and x plus 2.
X plus 5 and x plus 2. Good work. Can't factor the other ones, so I'm done there. All right, here's really, if there's any surprises right now. Tell me something that's in common. Tell me something they share here. Something's being shared. 10, one thing they share. No 10? Today?
10.
Oh.
The x plus 5 and the x plus 2.
Okay, that might be the surprise. They share two things. Wow, it happens. They share an x plus 5 and they share an x plus 2. And notice, is there anything left over? No, I took care of it. I took care of the x plus 5s and the x plus 2s. Nothing's left. So that's it. There's your common denominator. So yes, sometimes they'll have more than one quantity in common. All right, need a little help here. 10 again. X plus 5, x plus 2. Does it need to get multiplied by anything? No, everybody see it matches. Does everyone see? That denominator is the common denominator. Nothing to change. 9 stays 9. Not the case on the next one. What do I have to multiply the 3 by? 18, Tim?
X plus 2.
X plus 2. And I'm going to get 3x plus 6. What should I be multiplying the next fraction by here? 12?
X plus 5.
Yep. Now, anybody going to tell me anything here? Self-respect. That's what you should be telling me. Self-respect, Ryan. Why? Yeah, you should be distributing a negative one. Perfect. Self-respect. Distribute a negative one, not a positive one. So it's going to be minus x, but you're not going to see plus 5 on my numerator. You're going to see minus 5.
Oh.
Got to distribute the negative 1.
Can you go over again why you multiply the numerators by the x plus 2?
Okay, this one here. Ready? This second fraction. What is in the denominator?
X plus 5.
Okay, what's my common denominator?
X plus 5 and x plus 2.
So what's my denominator here missing?
The x plus 5.
Well, I got an x. Look, I got the x plus 5 in the denominator, right? I want to make this denominator look like my common one.
Okay, so you do x plus 2. So it's
Correct.
just like opposites.
Whatever it's missing.
Whenever it happened. Okay.
Whatever it's missing, okay? I want to make each denominator look like the common one. Let's keep going here. Let's see, I got 2x on top, plus 4. No, 10. Come on. I forgot that's 6. You're better than that. It's embarrassing. Not going to leave it like that on Friday. Going to keep going. Why? 7. Why am I going to keep going on Friday?
You can take 2 out of 2x plus 10.
Yep.
And then you can cross out the x plus 5.
All right. Yep. See you later, right? Go on. 2 over x plus 2. Any issues? I got one more to do and then it's grind time. We haven't done one of these in a few days, but I did throw this type on the quiz Friday. Prove, right? Prove the identity, meaning we got to get one side equal to the other. Work on one side, cross my fingers, I know my math, and it looks like the other side eventually. I start at the equal sign. What do I draw? There we go, a little vertical line. Now we got to make a class decision. What side do I work on? Because if I pick one side, I got to work on it and try to make it look like the other side. Any discussion on what side you want to work on to make it look like the other?
I agree.
What do we want?
Left.
Left? Okay, my first question is, what do you want to do? Because you're not crossing off those x cubes. What do you want to do with the left side then? If you want, look, I'm open to anything. If you want to work on the left side, though, you got to tell me what you want to do, though. Because your first step, obviously, is not cross out x cubes. You know, that's a no-go. That's an embarrassment in here, right? You factor in any of that?
Wait, what was right?
You're the one that said the left, so I'm rolling with it. You and your boy back there said the left, so I'm like, all right, let's roll with it. So maybe not.
Yeah, because you can factor the right.
I can't do anything, right?
Yeah.
The right side now, I have 2 fractions, don't I? 1 and 1 over x cubed plus 8. Yeah, everyone agrees?
Yeah.
All right, so have we been adding fractions? So why can't we add these 2? What's the denominator on the 1?
1.
A 1, right? 1 over 1. All right, give me a common denominator. I got 1 and I got x cubed plus 8. I'm not trying to trick you. What's the common denominator? X cubed plus 8. Yep, here we go. You found a common. I can't, there's no factoring here. Sorry, I can't factor that. You know that. All right, now you got to tell me what do I have to multiply both fractions by? This denominator was a 1. That denominator is x cubed plus 8. What do I have to multiply by? X cubed plus 8. So multiply the top, x cubed plus 8. And what am I going to get? X cubed plus 8. Yeah. I know you're going to think like this is way too easy, but you're doing it correctly. All right, go to the second fraction. Look at the denominator, x cubed plus 8. Any need to multiply by anything? No, so I'm going to write what? Plus that 1 in the numerator. There's no need to multiply because they matched. Combine your like terms. I know some of you are like, this can't be right, but we're fine. Combine your like terms. What do you get up top? X cubed plus 9 over x cubed plus 8. Anybody take a peek to the left? We did it. All this was adding 2 fractions. I know you get nervous because there's a 1 there, but adding 2 fractions without the same denominator. We were good. And you know I'm a stickler for this. Write it out. Write it out. Yeah, I didn't. You guys that said the left, I wasn't too sure what you were going to do with the left. If you're going to work with somebody else or working by yourself, I don't care. We need to start getting in the habit of having a Chromebook open to Google Classroom so you can see every time if you got an answer right or wrong, and calling me over if you got it wrong. Okay, so let's go. Split up. Stay by yourself. I don't care, but you need a Chromebook open. What do we got? 10:51. Come on, let's go. 16 minutes. Plenty of time.